All right, the first thing I want to do today is I want to look at this payroll nightmare worksheet. So I mentioned it in the, make sure that you're going on D2L and looking at each week. So for instance, for week 9, I have a description and a 1, 2, 3, 4, 5 of everything you should be doing this week. So make sure you're staying on top of that. So if you haven't done this and yours looks like mine, then you need to pause the video and go do it, kind of like we would do in class. Okay, you're not going to get the most out of it if you're just copying down what I say. Okay, so if you haven't done this payroll, the front and the back of it, or the 2 pages of it, make sure you pause the video. But then we're going to go ahead and proceed. So we've got 2 salary options, right? The first salary option is that we make $2,000 a week forever. Okay, so I'm just going to say it goes all the way down, right? The last one is also $2,000. But in this next column, we're figuring out cumulatively how much we would have. Okay, in other words, like how much have you made that year so far? So this would be 6,000, 8,000, 10,000, and then so on and so forth. Just make sure you know that after 10 years, we start skipping. So notice we're not going to go up by 2,000. We're going to go up by 5 2,000s. In other words, by 10,000. So this would be 30,000. Go up by 5 again, and we would be at 40,000. 5 more weeks, and we'd be at 50,000. So the function here is relatively easy to determine. It's just 2,000x. Okay, so salary option 2, and we've done some options like this before, right? We've talked about how powerful doubling can be, right? It is a much quicker growth. It's a geometric pattern instead. So here we're doubling our salary every time. So, you know, at first we're pretty underwhelmed by how much we're making, right? We're probably pretty unhappy about this salary option. But not surprisingly, it is in the upper levels when we start to really kind of take off. Okay, so it's probably helpful if we wait and pause here and come down and figure out what this formula would be. Notice that we're always taking the first week's salary, which was a penny, and then we're multiplying it by a power of 2, right? So this would be times 2 to the x minus 1 power. Okay. Notice it's kind of easier to go back and get the formula. Notice that would work, right? Because in week 2, we're going to multiply by 2 one time. If you plug 2 in here, you're multiplying by 1 power of 2. Okay. So that would be the formula. By the way, you could also get this formula by just looking at the geometric term formula, which just says that you do a sub 1 times, remember, r to the n minus 1 power. Okay, so that would have worked too if you couldn't eyeball that. So if you use this formula we just determined, you can get these values. So 25 years is pretty nice. 25 weeks, sorry. Notice in the 25th week, we're making a lot more, right? Because the doubling has a lot bigger effect. So let's also talk about cumulative. So cumulative would be where we would add it up, right? Let's write this out. I think I said it, but a sub n would be a sub 1 times r to the n minus 1 power. Okay. Notice this is still a geometric sequence, right? But I need to find the geometric sum. Okay, so we did this right before test 1, and here's the formula for geometric sum. S sub n equals a sub 1 minus a sub n times r, and then all over 1 minus r. Okay, and notice the terms we're asking for, that's the first term, and that would be the last term. In other words, if we want the 25th sum, then we would just need to use that 25th number. So we can just add the previous values. So this would be... we'd make 1 cent, right? And then we'd make an extra 2 cents, and now we're making 4 more cents. Notice you really can just take this value plus the next one, right? So this would be 15 cents. 15 plus the next value of 16 cents is 31 cents. So again, we're not being overwhelmed by our salary until we get to the end. Okay, so here's where we might want to go ahead and use our formula. But if you use the formula, you'll get 327 67 here, 10,485, 75 here. Okay, and again, if you want to know how you figure this out, you use this formula. S sub 20 would be the first term, which is always a penny, minus the 20th term, which we have here, times the R, and then over 1 minus R. This one would be pretty sizable. And so if you plug everything in here, and remember that actually if you plug all the numbers in, so 0.01 minus whatever your last term is, right, times the R, when you put it over 1 minus R, that's just going to be a negative 1. So there's a couple ways you could write this, but you end up getting negative 1 cent and then plus 1 cent times 2 to the x. Okay, so that's just what you would get if you performed that operation kind of over and over and over. Notice that what I really just did was took the first term, which is this, plus the a sub n term, right, or a sub x in this case. Okay. All right, so make sure, maybe pause the video, make sure that all of those values are equivalent, because we're going to need to be able to turn this form over and graph these things. Okay. All right, so let's look at number 2. Okay. First, let's skip number 2 just for a bit. We have 2 formulas, right? We have a linear equation, which is y equals 2,000x. And then we have a definite nonlinear equation. So this is what I wrote from the other side. If you wanted to, you also could factor out a 0.01. It might be a little bit easier to think about. If you factor out a 0.01, you're going to get 2 to the x minus 1. More specifically, you'd get negative 1 plus 2 to the x, okay, which could just factor this way. But when I say or, I really mean or. I just think that's a more compact way to write it. All right, so we need to come up with the cumulative salary options for both equations. Okay. So what we're going to want to do is decide which one is our dependent and independent variable, right? Our dependent variable is certainly going to be what week we're on, because what week we're on determines what our salary is. Okay, so I'm going to change the instructions here on this worksheet just a little bit. We're just going to look at not the cumulative weekly salary, but just the weekly salary. Okay, just kidding. No, I was going to change it up, but let's not do that. Okay, so the cumulative, let's just leave it as it is. Okay, I think that will be fine. So we're just going to leave it as cumulative salary. So notice for, let's go to the back, okay. Notice for this first one, we only need to go up to 50,000. So what I chose to do, you do need to come up with some sort of scale. What I chose to do is count by, I think, every 2 units was like $5,000 or something. So if you haven't done this already, again, remember you can pause the video. But you want to pick a scale that's appropriate. We're going to practice picking scales that are appropriate on the calculator here in a little bit. And then I think I just kind of sectioned this off kind of evenly. So I think what I did is I did 5 weeks here, 10 weeks here, 15, 20, and then finally 25. I think I just evenly kind of spread it out there. So notice the linear graph is pretty easy, right? So we just need to plot the line. We always start at 0 here. So you might want to get like a straight edge to make the lines nice. These grids are so small, my eyes are having trouble adjusting. All right, so very simple linear curve here, right? Really should go through that last point. Okay, so this is salary option 1. Okay, so clearly linear. Obviously from the equation we can tell this next one is exponential. So notice the values are really, I'm going to use a different color. The values are really, really tiny at first. So I'm just going to go by 5s, and you can look back at this page and figure it out. At 5 weeks we were at 31 cents. So I mean barely even registering, right? Like it really should be pretty close to the line. At 10 weeks we were only at $10, so still barely registering since we're counting by 5,000s. But 15, 20, so 15 we're at 300, so it's going up a bit, but not a whole lot. Where the action really happens is at the end. So at 20 years we're at a little over 10,000, just barely over 10,000. And then at 25 weeks, we're way, 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 way up there, right? Notice that we're supposed to be all the way up at like 300, right? So maybe like all the way up here. So what we're really trying to find out is, what would this look like? So exponential graphs do have this kind of look to them, right? So we're kind of fudging it just because that salary really, really takes off, right? So this would be salary 2. Okay, so obviously pictorially, if I ask you what's going on, kind of like the graphs we looked at last time, but definitely more complicated. Notice that graph salary option 1 is the better option until you reach a certain point, right? But then salary 2 is a much, much better option cumulatively. So if I ask you which salary is the best choice for the company, okay, that would kind of be, this is one of those questions I might ask my students that might have more than one answer, and as long as they give me an intelligent response, then I would be okay with it. So I might have people say salary 1 because I don't know how long I'm going to be at that company, okay? Because honestly, if you're not going to stay past a certain number of times, then you need to go with salary 1, right? But most people would say salary 2 because in the long run it's better. So I'm going to say you will make considerably more money in the long run because it's a lot more. Okay, but notice this is actually going to be number 5. This is where I want to spend most of our time, and I want to practice some stuff on the graphing calculator. How many weeks would this person have to work before option 2 is the better salary? So basically what you're trying to do is solve, when is 2,000x going to equal my 0.01 times 2 to the x minus 1? Okay, and notice that's actually a really hard thing to solve, right? We could use logarithms if we want to, but logarithms with a linear function over here is going to be a real challenge, okay? So what we're going to practice doing is we're going to use our calculator. And we're going to practice finding intersection point. There's all kinds of things the calculator can tell us. But first we're going to have to do some work on the windows. Okay, in other words, if we try to graph this traditionally, okay, so let's just practice it. If you tried to graph both of these graphs, so if you want to graph more than one thing, you can use Y1 and Y2. So mine is a color screen, so it is going to color the graphs a little differently to differentiate them, but you don't have to have a color screen. So if I enter in my 2 equations into Y1 and Y2, and then I hit graph, notice it did graph my blue. You just hardly couldn't see it, right? It's so steep that it's really not showing what I want it to show, right? And the issue here is that our window's all kind of jacked here, right? So I'm going to put this kind of side by side, okay? And we're going to write out how to change the window in just a minute. But for now, we'll just kind of keystroke it together and see if we can work this out. So when you go to your your window, you want to make sure that it matches your graph. So notice my x-axis is in weeks counting by 5. So I'm going to go from 0 to 25. And x scale is what that XC or XSCL stands for. So I'm going to count by 5s. Okay. And then notice on the y-axis, I want to go from 0 to maybe 50,000. But I want to count by 5,000s. Oops, one too many zeros. Okay, so notice if you do that, you get a much better interpretation of what the graph is. Okay, so when we teach our students to use these graphing calculators, we're definitely going to have to teach them how to pick an appropriate window. And notice it was much easier for me to pick out a window because I'd already kind of sketched it by hand. Okay. So we're going to put the worksheet off to the side for a minute. I do want you to write down what I have here. Okay, so I want to make sure you know how to change your window. Okay, so changing the window on the calculator is relatively easy. Okay, but this is the process that you do. You press window, okay, and you change your X-min, X-max, your scales, your Y-min, your Y-max, your scale, and then you press graph. Okay, when you want to cycle back to the regular window, you can just push zoom, and then number 6 is Z standard. Oops, sorry, I didn't realize I was in the glare there. Let me move that. Anyway, you can push zoom and then go Z standard, and it'll go back to the standard viewing window, which is -10 to 10 on X and Y, and going up by a factor of 1. Okay. So let's look at how to find intersection points. Okay, so I'm going to go ahead and let you write this down, jot this down. Okay, and then we're going to practice and kind of view some other things. So to find intersection points, you're going to go y equals, enter in your equations, which we've already done, right? You're going to adjust the window if needed, just like we just did. But then in the calculate menu, so let me slide this up a bit. So on your graphing calculator, if you look here, it says CALC, which stands for calculate. There's all kinds of things that you can do from the calculate menu. I'm having glare probs. Hang on a minute. Okay, there we go. That's a little bit better. Okay, so notice you can find a specific value using the cursor. You can find a 0, which is the same thing as an x-intercept. You can find a min or a max. Within a window, it's actually a relative min or a max. But what we're going to look at is this intersect. Okay, by the way, you can also do, look, number 6 and number 7, you can do derivatives and integrals there as well, derivatives and antiderivatives. So those are pretty helpful features, but we're going to look at the intersect. Okay, and then it uses an algorithm, which is just a fancy way of saying it uses a pattern. So what it wants you to do is it wants you to verify that your blinking cursor is on the first curve. Okay, it doesn't really matter which one's the first one, by the way, but it's also going to ask you for the second. So notice my cursor's on the line, so I'm going to say, yes, it's on the line. Okay, and then if it weren't, by the way, you would move it with arrows here. Okay, so now if it's asking, it's a little hard to see, I understand, but on your calculator it'll say something like second curve question mark. So this blinking cursor, is that on the second curve? And I think we can say yes. And then it asks you, do you want to guess? And if you want to, you can. I never guess. Okay, I just push enter and let the calculator do the guessing for me. But if you push enter again, it's going to tell you about what the intersection point is. Okay, so let me see if I can get that kind of viewing. You might have to zoom in, but notice right here is where it tells you where the intersection value is. Okay, so it gives you a value of about 22 point something. Okay, so we get x is approximately like 22.07. But we wouldn't break out weeks into that. Notice 22 is a little too small, right? So we need to answer the question, which is what week it would be. So by week 23, you'd bump it up because 22 is not quite enough. Option 2 is better. Okay. So on your homework for this week, or for this class time, I want you to really kind of look. You're going to do some more function activities. I don't expect everyone, this is unusual, but on the homework that I am assigning for today's class, I don't expect everyone to have the same results. So keep that in mind. So when you go to, if you get out the homework, which is called like weekly payroll or something like that, I think it's called weekly payroll, something. Look it up online, because now that I'm on the spot, I don't remember what it's called. But what you're going to do is you're going to look that over, and then you're going to have to try to create a line of best fit, okay? And so you just pick any 2 points and you find the slope between those 2 points. So I don't expect you all to pick the same values, okay? I don't expect you all to pick the same points to work with, but just see how far you can get on that homework. The homework for this week is going to be due Sunday. So the homework that I posted last time, which was graphs to stories and stories to graphs, both a 2-page document, that's going to be due Sunday, and then the one that I posted for today is also due Sunday. Okay. So as usual, just email me if you have any questions or concerns. If you haven't gotten on the activities and submitted the assignments that are already due Monday and the ones that are due going to be due Wednesday, you need to get on that ASAP.